So we're now looking at cumulative frequency graphs. Remember, cumulative frequency is a running total of the frequency. Cumulative frequency histogram is a column graph of the cumulative frequency. You know, it's like a histogram but no gaps. Notice it keeps going up because the cumulative frequency is the running total of the frequencies. Frequency histogram, notice it'll always keep going up, or sometimes it'll stay flat because this means that there is no score for number 9, because the number of frequencies so far with number 8 is 14, but the number of frequencies so far when we get to number 9 in the table is also 14. Cumulative frequency is, just looking back at this booklet 902, the median and the mode, we did cumulative frequency a few times. We did it in question 7 where it said number of biscuits broken, the frequency was 3, right? For 0 biscuits broken. The frequency was 8 for 1 biscuit broken. The cumulative frequency is the running total of the frequencies. So far 3 frequencies, then 3 plus 8 is 11. 11 plus 5 is 16. So when you do a cumulative frequency graph, you're graphing the x, not with the frequency, but you're graphing the x with the cumulative frequency. Okay? So you have the x on the lower scale, and the cumulative frequency is your new frequency. So, if you look at this graph here, do you know how many times the score number 4 occurred? If I was to draw up a little table, watch. The score number 4 occurred how many times? Once, because that's the frequency. But the cumulative frequency is 1. See, this graph is score and cumulative frequency. The number score 4 has a cumulative frequency of 1, which meant it must have had a frequency of 1 because that's my first score. Look, score number 5, what's its cumulative frequency? Now, what was its actual frequency? Do you get it? 1 plus 2 would have given me 3. Do you get the idea? Score number 6 has a cumulative frequency of 6. So 3 plus 3 would have given me 6. Its actual frequency is 3. So what you do, if you ever see a cumulative frequency graph and you're trying to interpret it, draw up a table where you've got your score and your cumulative frequency, put them in, and then come back and fill in the frequency column. Because the cumulative frequency is the running total of all the frequencies. What it does, it tells you how many scores so far. And that's why it's useful for the median and the interquartile range. Okay? So, do you get that? So, I should make some more room. Score number 7 has a cumulative frequency of... Actually, I am going to make some room. One sec. I'm going to put all my scores, which are from 4 to 12, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And I'm just going to fill in my cumulative frequency column. Because it's a cumulative frequency graph, do you see? Cumulative frequency, that's all I can read. Cumulative frequency for 4 is 1. The cumulative frequency for 5 is 3. Cumulative frequency for 6 is 6. The next one's 10. What's the next one? 14 and 14. 14 for 8 and 14 for 9. And then we've got 16. And then we've got 17, and the last one is 20. So, this tells me how many scores. I can now tell how many scores. This must have occurred once. 1 plus something is 3. It must be 2. 3 plus something is, 6 plus 4 is 10. 4. Now, 14 and 0. So the score number 9 actually doesn't occur. Then we've got 2. 1, 3. Now, guess what? You can actually read it from the graph, and it's a certain number. The frequencies are the gaps between the graphs. See, this was 1, and now it's 3, so 2 got added on. So that's, see, this is my first frequency, 1. This 2 is the gap between there and there. This 3 is the gap there. Do you see that? The 4 is the gap. There's another 4, but there's no gap between these two columns. They're the same height. That's why the frequency for number 9 is 0.
Is that a question?
Yes. Because cumulative frequency is a running total of the frequencies, it never goes down. But it can sometimes stay the same if the score doesn't occur. So the score number 9 there was no frequency for it. That's why the cumulative frequency graph stayed the same. Now, the really good thing about cumulative frequency is I can work out where the middle of the scores is. Now, are we good? So that just shows you how many scores so far. Now, to tell how many scores there are, how many scores altogether, girls? How many scores so far at the end? No, no. How many scores? There's 20 scores. There are 20 scores altogether. The total frequencies, the sum of the frequencies, if I added these all up, if I got a total of the frequencies, they would be 20. You never do a total of the cumulative frequencies because the cumulative frequencies is already the total. Wanted to write out the scores. The score 4 occurs once. The score 5 occurs twice. The score 6 occurs 3 times. The score 7 occurs 4 times, etc., etc. You should always have that visual idea of what your scores are. Now, if I add up my frequencies, it's 20. But you'll always notice when you do a cumulative frequency table that the bottom answer is always the total of the frequencies because cumulative frequency is a running total. How many frequencies so far? The last answer here is the total. How many frequencies there are? How many scores there are? Okay? Now, because we know there are 20 scores, can I move this table? There are 20 scores, so 100%, the 100% top of my data is at cumulative frequency what? 20, because I've got 20 scores. Now, girls, with a cumulative frequency graph, we can't go, I've got 20 scores, I'm going to put 10 to the left, 10 to the right. We don't do that. All we do is, what's half of 20? So at cumulative frequency 10, so it's actually just a bit of an estimation, this method. At cumulative frequency 10, because 50% of 20 scores is 10, is where my median's going to be. Now, you need a ruler. I haven't learned how to draw these. When you draw a histogram, don't draw anything yet. You're supposed to join the top centers with a normal histogram, with a normal polygon, but with this you don't. You must join the corners. So, you join the corners. Why? Because it's a cumulative frequency and it's telling you how many so far. So a cumulative frequency histogram, a polygon, is just where you join the corners. You go from one to the corner, not to the centers, please. Not like a normal polygon. So please, we join all the corners. And you never go back down like with the other one. Notice there's no gap, half gap column width at the beginning, like there is for a frequency histogram. Cumulative frequency histogram has no gap, half column gap at the beginning. Just join the ends of the columns. So if you want to read off your median, what you do, you come across at 10, you hit the line. I should do this in another color. Ladies, this is a histogram, the column graph. The polygon is the line graph. But for a cumulative frequency polygon, which is called an ogive, you must join the top corners, not the middles of the columns, all right? Now, okay, now it says in a cumulative frequency polygon, the top of the ogive is 100% of scores. The median is 50%, which is halfway up the vertical axis. The lower quartile, it all makes sense, is at the 25% mark, and the upper quartile is at the 75% mark. And to find an estimate of each median and the quartiles, you'll follow the arrows from the vertical axis down to the horizontal. Now, you know, if you've got, I'm going to put percentiles here. If this is 0 and that's all my data, this is 100%. Does this make sense? At 20. You know how we said the 50% mark is at 10? Where do you think, we'll do these others in a minute. So I say, right, this is halfway up my data. I come across and I come down. Girls, you've got to come across to hit the line and then come down. Where is the median? Very good. It's halfway between 7 and 8. So 7.5, because it's between, exactly on the border. Actually, I'm not even going to write between. I'm going to write on the border. It's on the border of the 7 and 8 columns. So, please, that's really important, is that the median is on the border of 7 and 8. Quartile, 25%. So 25% of 20 scores will occur at cumulative frequency 5. Does it make sense?
Yeah.
Like if that's 100%, 50%'s there, a quarter of the way is at 5. So you're going to have to estimate where that is. And yes. Now what you do here, yep, it's there. It's at 5. Sorry, you can't see that. So 25% will be here at 5. Do you get that? That would be 5. And then you come down and you read it to be 6. Are we good with that?
Yeah.
So lower quartile, please don't call the lower quartile 5 because you're reading across at 5. Don't do that. You've got to come down and read the score off the bottom. And upper quartile, I've made a mistake here, is at 75%. So I go 75% of 20, or 3/4 of 20, is at cumulative frequency 15. I have to come across at cumulative frequency 15, yep, which is here. And that's my 75% will be at 15. And my upper quartile is 10 because you come across and then come down and read. So therefore the interquartile range is what? 10 minus 6, which is 4. Now, you don't go joining the middles of the columns because look what would happen if you join the middles. Sometimes you're going to hit outside the columns and you can't read them. So you must go from the corners to the top corner of each column every single time because it's how many scores so far. It's sort of to the end of that number. Here's the cumulative frequency polygon. Actually, we haven't drawn the polygon yet to find the median. So first thing, let's draw this polygon in, which is joining the top. We're going to find the median, the 4th, 7th, and 9th deciles. Before we do anything, join the top right corners. Be very careful with some of them. Must join the corners. Otherwise, you're going to end up out of the columns for some readings. Okay, that's not a great one there. So, great. So 100% sits up here. So 100% is at cumulative frequency 30. Where do you think the median's going to be at? 50% is at cumulative frequency 15. Because it's 50% or half of 30 is 15. Now, girls, how much do you think it's going to be in each decile? Yeah, so to work out how much is in a decile, I'm going to go down here at the bottom for deciles. 30 divided by 10, 3 scores in each decile. How are we with that? If you've got to break this data up into deciles, you're breaking it up into 10 parts. So I've got 30 scores altogether. If 100% is there and 50% is there, if I want deciles, it's 10% of your data. So I would go up by 3s. But all we need to do for the third decile, let's do the median first. So the median we said was at, why am I there? I've made a mistake. Oh, it's still got more, don't worry. It's all right, I got one. So girls, sorry, I've come across at the wrong spot. So the median is at 15, isn't it? Yeah, at cumulative frequency 15. Come across at 15, not at 17 like I just did. Ooh. Come across at 15 until you hit the line, not the column. Now, I don't hit the line till there. Are you okay with that? I have to come and hit the line, not the column. And then I come down. I think I need a red pen so we can see. Cross with your line from 15, which is at the 50% mark, because 50% of 30 scores is 15 scores. You must hit the polygon. the line graph, not the column. You've got to hit the line graph. When you hit the line, you come down. So now, what is the median? It's on the border of the 4 and 5 column. So it's 4.5 because it's on the border of 4 and 5. Now, the third decile, girls, all I do is 30% of 30. What's that? Because third decile is at the 30% mark. I've got 30 scores. 30% of 30 is 9. It occurs at cumulative frequency 9. I come across at 9. Now be careful here. You do not estimate. This is very, very important to listen. Girls, you do not call this 4.1 or 4.2. So when we come across at 9 and we end up in column number 4, notice I'm in column 4. Whether I end up at the beginning of column 4 or at the end of column 4, I call it 4. Now, it's going to be different over the next page. It's because this is discrete data. The scores are whole numbers. So, just watch. Let's say I did write this data out, right? If I did write the data out, you would hit number 4 would be that 30 percentile mark. Because I'd have to write out the scores. You know how I've got 15 scores, like 8 scores so far up to number 2, up to number 3. The 9th and the 10th score and all that will be 4. So the third decile will be 4. Look, when it's discrete data like this, see how it says score and they're whole numbers? You do not approximate. If it sits inside column number 4, the answer is 4. I do it for the top one when there were less scores. I'm going to come up here. You know how we went to the border here and we said that the median was 7.5? I'm going to write out the scores. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a line. You know how there's 20 scores? And then the number 8, I think, occurred 4 times. The number 9 did not occur. 10 occurred twice. 11 occurred once. And 12 occurred 3 times. Now, watching. So, if I did write the scores out, look where the median is. Look where the median is. It's halfway between 7 and 8. For the first example, I wrote all the scores out, 10 on the left, 10 on the right, put the line in between. Can you see the median is between 7 and 8? Right. But if I look at the lower quartile, that goes 1, 2, 3, 4, 5. It was there. And the upper one was here. So when it occurs, girls, between in that column, it's like you've got the same numbers on each side. The average of that and that is just 6. The average of that and that is just 10. So when you hit inside a column, it's just that number. It'll just be between 2 of the same numbers in the column. All right? But when you hit a border, you're going to hit one of these. All right? So let's just finish this off. It only will take a minute. 77th decile is 70% of 30 scores, is cumulative frequency 21, come across at 21, and it sits in column number 6, is 6, and 99th decile, which is 90% marks, and 90% of 30 is 27. We come across at 27. And it doesn't matter where in the column you sit, it will be 8. Now, the story is going to be different if the data is not discrete data like this. This is discrete numerical data. Okay, you just read off in the column that you're at.